Hello, my name is Mario Lozano, and in this video I'm going to analyze and explain the contributions and main elements of research of the paper Encoding in Style as StyleGAN Encoder for image-to-image translation. This paper was presented at the Conference on Computer Vision and Pattern Recognition 2021 by researchers from Penta AI and Tel Aviv University. In recent years, generative adversarial networks, GANs, have significantly advanced image synthesis, particularly on face images. State-of-the-art image generation methods have achieved high visual quality and fidelity, and can now generate images with phenomenal realism. Most notably, StyleGAN has recently been established as the state-of-the-art for image synthesis with unprecedented visual quality. StyleGAN departs from the usual architecture for the generator, introducing a control of how the latent code modifies the images. Moreover, it has been demonstrated that it has a disentangled latent space, W, which offers control and editing capabilities. With the rapid evolution of GANs, many works have tried to understand and control their latent space, and recently, numerous methods have shown competence in controlling StyleGAN's latent space and performing meaningful manipulations in it. A specific task that has received substantial attention is GAN inversion, where the latent vector from which a pretrained GAN most accurately reconstructs a given known image is to be found. Motivated by a state-of-the-art image quality and latent space semantic richness, many recent works have used StyleGAN for this task. These works usually resort to using a per-image optimization into an extended latent space, W+, and this typically requires several minutes for accurately reconstructing a single input image. Some recent works design an encoder to learn a mapping between a real image and its corresponding latent representation. However, in terms of reconstruction quality, there remains a significant gap between optimization-based and encoder-based inversion methods. Therefore, designing a proper encoder and training a sim remains a challenge with much work to be done. All these methods follow an invert first, edit later approach, when one first inverts an image into a StyleGAN's latent space and then edits the latent code in a semantically meaningful manner to obtain a new code that is then used by a StyleGAN to generate the output image. However, it has been shown that inverting a real image into a 512-dimensional vector belonging to the latent space does not lead to an accurate reconstruction. This differs from the approach shown in this paper, which directly encodes input images into the corresponding output latents, allowing to also handle inputs that do not reside in the StyleGAN domain. For solving the GAN inversion task, the authors introduce a novel encoder architecture tasked with encoding an image directly into StyleGAN. The pixel-to-style-to-pixel (PSP) framework provides a fast and accurate solution for encoding images into the latent space of a pretrained StyleGAN. This encoding can then be used to easily manipulate and edit real images directly in the latent space. What really makes PSP even more interesting is that it can be applied to more general image-to-image translation tasks by directly encoding the input image into the latent code corresponding to the desired output image. Using this technique, one can perform image-to-image translation even when the input image cannot be encoded into the latent space of the pretrained StyleGAN. The encoder is based on feature pyramid network, where style vectors are extracted from different pyramid scales and inserted directly into a fixed pretrained StyleGAN generator, in correspondence to their spatial scales. Starting from an input image, the PSP architecture goes as follows. Feature maps are first extracted using a standard feature pyramid over a ResNet backbone. For each of the 18 target styles, A small mapping network is trained to extract the learned styles from the corresponding feature maps. The mapping network, mapped to a style, is a small fully convolutional network which gradually reduces spatial size using a set of two straight convolutions followed by a leaky ReLU activations. The generated 512 vectors are fed into a pretrained StyleGAN, which then generates the output image. While the style-based translation is the core part of their framework, the choice of luces is also crucial. Using a carefully chosen set of luces, they show that their encoder can efficiently and accurately reconstruct real input images without requiring time-consuming optimization. In this picture, we can see the results of PSP for StyleGAN inversion compared to other encoders. As can be seen in the last row, the PSP framework is able to preserve identity while also reconstructing fine details such as lightning, hairstyle, and glasses. Okay, so what can PSP do? Many previous approaches for image-to-image translation involve dedicated architectures for solving a single task. On the other hand, the proposed pixel-to-style-to-pixel framework can be used to solve a wide variety of image-to-image translation tasks, including StyleGAN inversion, multi-modal conditional image synthesis, face frontalization, inpainting, and super resolution. In conditional image generation, given as input segmentation maps, PSP can generate realistic faces. We can see PSP in the last column of the image. Especially when compared to other well-known methods, we can see how this approach outperforms all the others. The same level of realism can also be achieved by introducing sketches as inputs. PSP still outperforms the rest of the methods, as we can see in the picture on the left. Moreover, PSP can generate multiple outputs from a given sketch, as we can see in the right image. Super resolution tasks are also suitable for StyleGAN. Additional tasks such as local editing or inpainting are also suitable. Moreover, thanks to this architecture, a generator can be easily trained with significantly fewer examples than required in the past. So we can, for example, have other domains such as animals. Nevertheless, there are some limitations. The high-quality images that are generated by using the pretrained StyleGAN come with a cost. The method is limited to images that can be generated by StyleGAN. Thus, generating faces which are not close to frontal or have certain expressions may be challenging if such examples were not available when training the StyleGAN model. Some examples can be seen in the following image. Also, the global approach of PSP does introduce a challenge in preserving finer details of the input images, such as earrings or background details. This is especially significant in tasks such as inpainting or super resolution. This is the end of the presentation. Thank you very much for your attention.